So today's topic is algorithm. What actually algorithm is? Whenever you get a problem statement, now the approach to solve that problem statement is called algorithm. Okay. Now you have different type of algorithm as you already know, like divide and conquer, like greedy, dynamic programming, backtracking, and all those. So today's discussion would be mostly on greedy algorithm. If we deep dive into greedy algorithm, what actually called greedy? Okay, and how you will understand a problem statement can be solved using this greedy algorithm or not. Okay, so first thing, let's suppose a problem is given. Whenever a problem is given, that problem may have different number of solutions. Let's suppose solution 1, solution 2, solution 3, and so on and so forth. Okay, till let's suppose solution 7. Okay, now all those solutions is achievable solutions. Okay, now in greedy algorithm, so whenever the problem will have some constraints, okay, if some constraints is given in the problem, then depending on that constraints, some of the solutions would be there which is actually following that constraints. Okay, I'll give you a proper example, then you will understand it in a better way. So depending on the constraints, which are the solutions following that constraints, those solution will be called as feasible solutions. Okay, now among those feasible solutions, if you try to find out which will take maximum or minimum, if it is a maximization problem or a minimization problem, then among these solutions, only one solution would be there which will be maximum or minimum depending on the question. So that particular solution would be called optimal solutions. Okay. So if any problem statement is asking for the optimal solutions, means if any problem statement is actually asking about the optimal solutions, then you have to understand, okay, that particular question or the problem can be solved using greedy algorithm. So for example, let's suppose I wanted to go from a city A to city B. Okay, now on which way we can go? We can go by bus, we can go by train, we can go by flight, we can go by our car. Okay. Now, if we try to understand how much cost it will take, so let's suppose bus is taking 100 rupees, train is taking, let's suppose 80 rupees. Okay. Flight is taking, let's suppose 2000 rupees, and car will take, let's suppose 1000 rupees. Okay. Now, one more thing would be there. So, bus, let's suppose it will take 12 hours to reach, whereas train it will take, let's suppose, 20 hours to reach, or flight it will take 2 hours to reach, and car it will take, let's suppose, 10 hours to reach. Okay, now you have two different things given. Okay, one is your price, means cost, and another is your time. Let's suppose in this problem it is given that you can spend maximum of 500 rupees. Okay, so the constraints is given. Now this 500 rupees is your constraints. Now constraints is given. Depending on that constraints, which would be your feasible solutions? Bus and train. Why? Because only bus and train costs less than 500 rupees. Now these two are feasible solutions. So let's suppose one more thing is given, but minimizing the time, your time should be minimum. So here two things are given, all your transportation cost and time is given, and it is said as a constants that your cost should be less than 500, and it is also said that your time should be minimum. Now you can understand it is a minimization problem with a constants, and these things are given. Whenever you get all those things, that time you will understand, okay, this can be solved using greedy algorithms. So here, depending on the greedy algorithm, which will be your optimal solutions? Your optimal solutions would be this bus. Why? Because bus is taking less than 500 as time as money, and time is minimum. So two feasible solution would be bus and train, and the optimal solution would be only bus. Why? Because it is following the minimum these conditions. Okay. Now this is actually the greedy algorithm is. This is whole about greedy algorithm. Now you will have a traditional greedy methods or approach, like you have knapsack problem, you have job scheduling problem. So we'll discuss knapsack and job scheduling problem now. Okay, so let me talk about what is knapsack problem. Okay, in knapsack problem, two things will be given. One is value and another is weight. Let's assume you have a knapsack or a bag, and that bag can have a maximum weight of 40. That is also given in the problem statement. So maximum weight of 40 you can carry on top of this bag. Now, each and every value would be given, and depending on that value, some weight would be assigned. Now, the problem statement is you have to take maximum value in this knapsack. You can understand? Now, in this problem statement also you can see lot of solutions would be there. So only this particular is something which you can choose. Now you can choose a combination of this and that. Okay, you can choose some other combination as well. So you have different solutions. Now all the solutions cannot be the feasible solutions. Why? Because let's suppose if you take 30 and 20, these two values, okay, then what it will be done, the weight is 40 plus 10 means 50, but the maximum weight is 40 is given. Okay, so that will not be a feasible solution. So you have to choose some solutions which is feasible solutions, and from that feasible solutions you have to find out the optimal solutions which will have the value as maximum. Okay, now how you will solve that problem? To solve this problem you have to find out value to weight ratio. Okay, so per unit weight, this is having 10 by 30. This is the value per unit weight. This is the value for the second. Per unit weight value would be 20 by 10. Similarly, for the next one the value would be 30 by 40 on unit weight, right? And the next would be 40 by 20. So per unit weight, what is the value? Now you have to sort it down. You have to sort it down in descending order. Then only you will understand that which particular value to be chosen. Okay, because the unit maximum value would be the thing which would be more profitable to you. Okay, then your value would be maximum. Okay, so here you can understand the maximum is this one. So since maximum is this one, 20 divided by 10 means 2. Since this is the maximum, at the same time this is also maximum, means both are having 2 as value. So now these 2 is something which you have to take. So you take this one, means value 20, plus you take value 40, means this one is selected and this one is selected. Now how much you have already used? You have already used 10 and 20. This much of weight means 30 weight you have already used. You have remaining 10 weights. Okay, you have remaining weights as 10. Now which one you will choose, the first one or the third one? So first one is having 1 by 3 and second one is having 3 by 4. Okay, so maximum would be 3 by 4. Now you have 40 as weight, so the whole thing you can take because you have remaining weight as 10. So what you will do, from that 40 you will take only 10. So one fourth you will take. Okay, so the value of one fourth of this value will be taken. So plus one fourth of 30 means 30 divided by 4 is something which you can take. So your maximum value would be this one. So in that knapsack problem you can take maximum of this amount. Hope this is understandable. Hope you understand the knapsack problem. Now the next kind of problem which we'll be discussing, which can be solved using greedy method or greedy algorithm, is job scheduling or job sequencing problem. Now, before moving ahead from knapsack problem, there is one more type of knapsack problem which is called 0-1 knapsack. And that 0-1 knapsack is a problem statement which can be solved using dynamic programming. Okay, so whenever we will talk about dynamic programming, we will see what is 0-1 knapsack. Okay, now we will be moving to job scheduling or job sequencing. Let's check. So here some of the jobs are given. Okay, now all those job is having some profit and deadline. So all those job is having some profit and deadline. Now here is given the deadline is the constants. Okay, here maximum deadline is 4, so you have a maximum deadline as 4. Okay, so this is the constants, and you have to maximize the profit. So which job you will choose to maximize the profit, and what would be the maximum profit? This would be the problem statement. Hope that problem statement is understandable, right? So one more I'm explaining. So you have profit and deadlines. Now, depending by seeing the deadline, we can understand 4 is the maximum deadline. So you have 4 as maximum deadline. So which all job you will choose to maximize your profit? So here also you can understand this is a type of problem where a maximization or minimization problem. At the same time, this can have lot of different solutions. So from that solutions, you have to understand the feasible solution depending on the deadline. Okay, some of the solutions would be feasible solutions. And once you get the feasible solutions, then you have to think about the optimal solutions, which will have the maximum profit. Hope this understandable. Now, let's solve this issue or problem. Okay, so as we have 4, okay, one more thing to keep it in mind in job scheduling, each and every job is taking 1 day of time or 1 unit of time. So each job is to take the same amount of time, and in 1 day, one job would be delivered. Okay, so let's suppose this particular job means job one, the person who gave the job one can wait till 3 days. Okay, it can be solved using only 1 day, but they are giving 3 days to solve this problem. Okay, so since the maximum day is 4, so let's suppose I have a 4 slot. Okay. So January 1, January 2, January 3, and January 4. So within January 4, I have to solve these problems. Means I have to take some of the jobs which can be delivered till January 4, because no of the person can wait till January 5th. Right? Because no one is waiting till 5 days. So maximum deadline is 4 days. So now job one is coming. Okay. Whenever job one is coming, whether I will take that job or not, how I will decide? Now I'm going through the solution approach, which is greedy algorithm. Now in greedy algorithm, first you have to check that my profit is 35. So you see, it is just in the descending order of our profit. So first job which will come, okay, which I will check, that should be the maximum profit. So 35. Now I'm checking whether I can take this job or not. Whether I will take this job or not, I'll check. Okay, I have day 3, means January 3rd. 3rd January, I can deliver. So, is there my place open for 3rd January? I will check. Yes, 3rd January is open for my job. So, let me assign job 1 for 3rd January. So, I'm taking it. Okay, now let me check for job 2. Job 2 can wait till 4 days. I will check. My day 4 is open for taking this job. Yes, my day 4 is also not assigned. So here I can assign the job 2 in the day 4th. Now 25 profit wala job means day 3, job 3. Job 3 is also expecting as day 4. Day 4, can I deliver it? No, I have already occupied. So I will check in the earlier days. Earlier days, can I deliver it? No, day 3 is also not possible. So I'll check day 2, means January 2nd, can I deliver it? Yes, I can deliver it. So I will assign my job 3 here. Now think about it. The job 3, the person who gave this job 3 will be happy enough. Why? Because they don't have any problem if they got the response previously. Means whenever the job is given, they can wait for 4 days, but we are not waiting for that job to be done for 4 days. So January 2nd is something where we will keep this job done. Okay, so day 3, I have assigned the job 3 in day 2 only. Okay, now the next, this job 4, can I assign it? Let me check. So it is asking, okay, January 2nd, I want it. So is my January 2nd possible? January 2nd? No. January 2nd is not possible because already I have assigned some job. So I'll check January 1st. Can I give it? Yes, January 1st I can give it. Why? Because I have a open position at January 1st. So I will provide this job for as my first slot. So first day I will build this job. means job 4, then job 3, then job 1 and job 2. So what would be my maximum profit? My maximum profit would be 20, now 25, now 35 and 30. So if you just sum up, then what it would be? 0, 11. So 110 would be the maximum profit for this job scheduling algorithm. Now, if you just change this particular thing, if you just change this particular approach or everything, okay, then maybe instead of job 4, job 3, job and job 2, you may select some different jobs. However, the profit would be maximum, but the approach would be same. If you don't understand, you just go back to the video and try to understand how you have to schedule. Okay, and I will provide some other job sequencing problem statement there. You can also refer to understand it. Okay, in later point of time, we will explain through Python code how you can solve this problem through Python code. These two are the traditional greedy problem statement. Okay, these are the problem statement which can be solved using traditional greedy algorithm. Thank you so much.